1 second. Yeah. First one is Chadamma Sangavi.
Rule 1 says the root locus is symmetrical about real axis.
Okay, this is rule 1. Next, rule 2.
Rule 2, number of root loci, RL branches.
So rule 2 gives the number of root locus branches based on 2 conditions. That is, one condition is number of open loop poles is greater than number of zeros. Then the number of root locus branches is equal to number of poles. And if the condition satisfied, second condition is satisfied, P less than Z, then the number of root locus. Power gone, amma. Power failed due to power failed.
Excuse me, sir.
Yeah, tell me.
Sir, I think in students, no one is presented, sir, to allow the login.
1 second.
Yes, sir.
ఏంటమ్మా ఏంటి
స్టూడెంట్స్ లో ప్రెసెంటర్ ఎవరు లేరనుకుంటే సార్ అలా చేయడానికి.
ఉన్నారమ్మా ఉన్నారు 77 యా ఎస్ అమ్మా
ఓకే సార్.
ఓకే ప్రెసెంట్ 77 చూసారు
సార్ ఓకే సార్
ఓకే ఎలా వచ్చాయమ్మా కొంచెం 77
Okay, sir.
Sangavi 74.
Yes, sir.
మీరు అన్మ్యూట్ లో ఉండమ్మా.
Okay,
నెక్స్ట్
sir.
79 కూడా ప్రజెంట్ చేస్తాను, నిలవచ్చండి. యా సంగవి. Okay now. So the rule number 2 is, what is the rule number 2? So it decides, the rule number 2 gives the number of root locus branches. So the root locus branch always starts at the open loop pole and where k equal to 0, and it terminates at open loop 0 where k equal to infinity. Where k equal to infinity. Next, third rule is, what is third rule, Amma? Sangavi?
Rule 3, sir. Real axis locus, sir.
Yeah. Whether the root locus is there on real axis or it is going to be checked. So how to check? So just consider a point on real axis. To the right of that point, if you are going to add number of poles and zeros. If you are getting an odd number, then there is a root locus between those two poles or zeros, whatever it is. So that is a rule 3. That is a rule 3, Amma. So next, rule 4. Rule 4 is asymptotes. Asymptote means the, so always if the root locus branches are 3, so these 3 root locus branches starts at open loop pole and they are going to be end at open loop 0. If there is no open loop 0 means all these all these root locus branches are going to be terminate at infinity. That means the open loop zeros are available at infinity. We can consider it. So that those root locus branches which are approaches to infinity, that root locus branches we can call it as asymptotes. We can call it as asymptotes. So number of asymptotes is equal to p minus z, p minus z. So in which direction the root locus branches approaches to infinity means that is given by the that is given by the angle of asymptotes. That is odd multiple of 180 degrees over p minus z, 2q plus 1 into 180 degrees by p minus z, where q equal to 0, 1, 2, 3 and so on, p minus z minus 1. This is the way you can find out the angle of asymptote. The angle of asymptote gives the direction along which the root locus branches approaches to infinity. That is rule number 4. And rule number 5, which is centroid. Centroid is the intersection point of the asymptotes on the real axis. So these asymptotes are going to be intersected at a particular point on the real axis. That point can be decided by the center. That point is given by the centroid. The centroid formula is sum of the real parts of the poles of the open loop transfer function minus sum of the real parts of the zeros of open loop transfer function over p minus z, over p minus z. This is the centroid. So how to calculate centroid already we gone through already. Next rule 6, breakpoints. If the root locus exists between two poles, then a breakaway point exists. If the root locus branch exists between two zeros, a break-in point exists. Breakaway or break-in. These two are breakpoints. So breakpoint may be a breakaway point or break-in point. A breakaway point exists if the root locus in between the two poles. If the root locus in between the two zeros, then a break-in point exists. So how there is a procedure to find out the breakaway point. First write the characteristic equation. Later form the equation in the form of k equal to f of s. Then differentiate k, dk by ds with differentiate k with respect to s, and that should be equal to 0. Then you are going to have whether so that we are going to check. This is the procedure. This is the procedure. After break calculation of the, so where the root locus intersect the imaginary axis, that is rule 7. The root locus is going to be intersect with the imaginary axis at what point? So that is given by that is RH criteria. RH criteria we are going to determine that point. So that point. So this is the procedure. Similarly, write the characteristic equation and form the route array and determine k value. So in this rule, you are going to have the marginal marginal stable. So you are getting the k value. At what k value you are going to have the marginal stable. At what k value you are going to have the marginal stable. This is rule number 7. Next, rule number 8. Rule number 8, I stopped there. That is angle of departure and angle of arrival. So rule number 8, which comes, which exists only when the roots of the characteristic equations are complex conjugate poles or complex conjugate zeros. If the roots may be complex conjugate poles or complex conjugate zeros, you are going to determine angle of departure or angle of arrival. So the angle of departure is calculated at complex conjugate poles. If complex conjugate poles exist, then you are going to find out the angle of departure. How to find out the angle of departure, sir? What is the purpose? What is the purpose of we are going to find out the angle of departure? We'll see in numerical in detail. I'm going to explain. Don't worry. So first of all, let us accept what is the angle of departure, where it is going to be calculated, what is the formula. The angle of departure is calculated at complex conjugate pole. So angle of departure gives with what angle the pole depart from the initial position. With what angle the pole depart from the initial position. So how much angle the pole is going to be departed from the initial position? That is what angle of departure from a complex pole. That is phi d. That is equal to 180 degrees minus 5. 100 degrees minus 5. 5 to చూపిస్తారు కొన్ని టెక్స్ట్ బుక్స్. In some text book they are using theta. So anyway, whatever it is, the formula is phi d is equal to 180 minus 5m. 180 degrees minus 5, where phi is equal to the sum of angles contributed by the poles from the complex pole minus sum of angles contributed by the poles from zeros, from zero. To the complex pole em. So phi is equal to sum of phi p minus sum of phi z. Sum of angles contributed by poles minus sum of angles contributed by the zeros. Sum of angles contributed by the zeros. So మీకు ఇప్పుడు అర్థమవుపోయినా? While doing the problem, it is understandable. Don't worry. This is the formula for angle of departure, which is calculated from a complex pole A. So, and whatever the angle of departure we calculated from a complex pole A, the same. The angle of departure from a complex pole A conjugate, if I take A conjugate, then that is minus of angle of departure from a complex pole AM. So clear. Here it is conjugate. If I want to find out the angle of departure from a complex pole A conjugate, that is equal to minus of angle of departure from a complex pole A. Already we calculated here. So that is. Then similarly, angle of arrival. Angle of arrival is calculated at complex conjugate zero. Complex zero దగ్గర మనం find out చేస్తాము. So angle of arrival at complex zero A, that is equal to 180 degrees plus 5m. 180 degrees plus 5. ఇక్కడ angle of arrival A తీసుకున్నాం. Angle of arrival కదా 5A. Let us take. So 5A equal to 180 degrees plus 5. అక్కడ వచ్చేసి minus 5. So here it is 180 degrees minus 5, but here 180 degrees plus 5. But phi is same. Phi is equal to angles contributed by the poles minus sum of the angles contributed by the zeros. So అక్కడ వచ్చేసి departure వచ్చేసి 180 degrees plus 5. minus 5. ఇక్కడ వచ్చేసి 180 degrees plus 5. 100 degrees plus 5. కన్ఫ్యూజ్ అవ్వద్దు. ఈ ఫార్ములా చేంజ్ అవుదాం. మీరు కొన్ని టెక్స్ట్ బుక్స్ కొంచెం కన్ఫ్యూజ్ చేస్తారంట. ఈ ఫార్ములాని ఇంకొక విధంగా చెప్తా ఉంటారు. సో డోంట్ కన్ఫ్యూజ్. సో just follow this one. So departure వచ్చేసి 180 degrees minus 5. Arrival వచ్చేసి 180 degrees plus 5. Phi is same in both. Okay. So angle of arrival at a complex zero A conjugate, that is equal to minus angle of arrival at a complex zero A. So మనం పైన ఏదైతే ఏ దగ్గర ఫైండ్ అవుట్ చేస్తాం, just take the minus symbol. So ఈ రూల్ వచ్చేసి రూల్ నెంబర్ 8 is which exists only when the root is either complex conjugate pole or complex conjugate zero. ఈ కండిషన్ వచ్చినప్పుడే రూల్ నెంబర్ 8 మనం అప్లై చేస్తాం. అదర్వైజ్ we doesn't use this rule. So two numericals I am going to explain. One is without a complex conjugate pole. One is one problem. Another one is complex conjugate pole. So how we are going to draw the root locus? And we can comment on the stability also. These are the rules of the root locus. So ఇవన్నీ కూడా నేను ఒకసారి సెండ్ చేస్తాను, చూసుకున్నాము. So now I'm going to explain the procedure to plot root locus. Already in the form of steps I delivered all the construction rules to draw the root locus. So finally in one document I want to write all the points. That is the reason here I wrote. Okay Namma. So Sangavi.
Yes sir.
Just read Amma.
Okay sir.
Yeah, first point you just read.
Procedure to plot root locus. Point number 1. Find out all the roots and poles from the open loop transfer function and then plot them on the complex plane.
Okay.
Second one, all the root loci start from the poles where k equal to 0 and terminates at the zeros where k tends to infinity. The number of branches terminating at infinity equal to the difference between the number of poles and number of zeros of g of s and g of s h of s. 3. Find the region of existence of the root loci from the method described above after finding the values of m and n. Next point, calculate breakaway points and break-in point if any. Next point, plot the asymptotes and centroid point on the complex plane for the root loci by calculating the slope of the asymptotes. Next one, now calculate angle of departure and the intersection of root loci with imaginary axis. Next one, now determine the value of key by using any one method that I have described above.
Yeah. So whatever the rules I delivered, the same rules here in the form of points they are giving. Clear? This is one. I mean, just procedure for to draw the root locus. In one document, I typed all these points. Okay. Anyway, so these are this is the procedure to plot the root locus. Now let us move to immediately. Let us move to the numerical sum. Numerical. So I don't want to waste the time. So already so time waste అవుతుందని ఆల్రెడీ నేను మొత్తం టైప్ చేశానమ్మా మార్నింగ్ 2 ప్రాబ్లమ్స్ 2 న్యూమరికల్స్ I type. So numerical 1, I mean problem 1, just read amma Sangavi.
Numericals on root locus technique. Problem 1. Suppose we have given the transfer function of the closed loop system as g of s into h of s is equal to k by s of s plus 5 into s plus 10. Construct the root locus for the system and predict the stability.
Predict the stability. So they have to given the open loop transfer function. Am I right? So all of you listen carefully amma. All of you listen carefully. So మీరు జాగ్రత్తగా వినండి అమ్మా. సో నేను ఇవి నేను సెండ్ చేస్తాను, తర్వాత నోట్ చేసుకోండి. ఫస్ట్ ఆఫ్ ఆల్ యూ జస్ట్ రైట్ డౌన్ g of s into h of s is equal, you just note down this one. G of s into h of s is equal k by s into s plus 5 s plus 10. Okay namma? So this is the open loop transfer function. For this open loop transfer function, I want to draw the root locus diagram, and later after drawing the root locus diagram, I am going to predict the stability for which k values the given system is exactly stable, and for which k value the system is marginal stable, and for which k values the value, I mean the system is unstable. This is what the prediction of the stability, predict the stability. So what is the flexibility which we have in the root locus? By varying the system parameter, from k is equal to 0 to infinity, so we are going to adjust the roots of the characteristic equation. We are going to adjust the roots of the characteristic equation to get the desired system performance. That is the flexibility that we should have in root locus technique by tuning the parameter k. Anyway, this is the given open loop transfer function. In the given open loop transfer function, how many number of poles and how many number of zeros? Sangavi, how many number of poles and how many number of zeros? So in the given
3 open loop poles.
Yeah, very good. So 3 open loop poles and open loop zeros?
2 sir.
2 na. Open loop zeros should. Sorry. Z value and how much?
1 0 sir, 0.
Yeah. So on the numerator there is no root on the numerator. So that means open loop 0 is equal to 0. So there are no zeros. Only poles are available. How many poles are available? 3. What are those?
3 sir.
What are those?
S is equal to 0, S equal to -5 and S equal to -10 sir.
Yes, there are 3 rules. I mean there are 3 open loop poles, and there are no zeros. So how many root locus branches immediately? So is it condition 1 or condition 2? So immediately Here we are having one condition. What is the condition? P is greater than Z. Am I right? This is the condition you are getting.
Yes, sir.
So P greater than Z. This is a condition 1. How many number? So according to this condition, how many number of root locus branches? How many
3
number of
root locus. 3,
branches?
sir.
Yes. Yes. The number of root locus branches is equal to number of open loop holes. That is P. That is equal to how much? 3. So 3 root locus branches. 3 root locus branches. So these 3 root locus branches. Okay, Nama. So here I pole 0 map I drawn here. So where I so this is imaginary axis and this is real axis. So the one pole is at origin, another pole is at minus, okay, na, -5, and another root is at -10. So all are poles. There are no zeros. Here I just indicated here, right side. I just indicated the pole 0 map. Pole 0 map. So immediately next, how many root locus branches? 3. How many root locus branches? 3. So 3 root locus branches. Where they are going to be start, Amma? Where they are going to be start? Chapama Sangavi. So where they are going to be start and where they are going to be terminate?
From 0.
So you can note the 3 root locus branches start at open loop poles. S is equal to 0, S is equal to -5, S is equal to -2. So 3 poles. So 3 poles దగ్గర మనకి root locus branch starts అవుతాయి. Where they are going to be end? If there is any open loop zeros? If there is any open loop zeros, Amma? No.
No, sir. No.
No open loop zeros. So that's why all the zeros we can consider. So all the 3 open loop zeros. Note చేసాను చూడండి. All the 3 open loop zeros. So ఇక్కడ rectangular ఇచ్చేస్తున్నాను చూడండి మీకు indication కోసం. I'm using rectangular. So all of you. All the 3. So all the 3 open loop zeros where I can consider infinity. Okay, there are no open loop zeros means open loop zeros లేవంటే ఎక్కడ మరి ఎక్కడ చేయాలి root locus branches? Infinity. Clear? So all the 3 root locus branches are going to be terminated in infinity. That's why. So all the 3 open loop zeros are at infinity. We can consider it. అర్థమైందమ్మా సంగవి?
Yes, sir. Yes, sir. అర్థమైంది.
So there are no open loop zeros actually. So but the 3 root locus branches where they are going to be terminated, they are going to be terminated open loop zeros at infinity. So we can consider మనం అనుకోవాలి. So infinity దగ్గర మనం ఎండ్ చేయాలని అనుకోవాల్సింది తప్పదు. ఎందుకని అంటే they are not giving open loop zeros. They are not giving open loop zeros. So whatever the root locus branches they are going to be started open loop poles where k equal to 0, compulsory they are going to be ended open loop 0. So they are not having open loop zeros. So compulsory those open loop zeros are considered at infinity. That's why these 3 root locus branches are terminated. See the second point I wrote here. See the 3 root locus branches started the open loop poles s equal to 0 and s is equal to -5, s is equal to -10, where k equal to 0 and terminated. Where it is going to be terminated? Where it is going to be terminated?
Open loop 0 at infinity where k is equal to infinity, sir. Terminates.
Yeah. Terminates at infinity దగ్గర మనం terminate. So how many asymptotes are there? Based on this point, how many asymptotes are there?
3 asymptotes.
Why you are telling 3 asymptotes? What is the meaning of, what is the definition of asymptote? What is the meaning of asymptote? Asymptotes are the root locus branches which are approaches to infinity. Any root locus branches infinity ki approach అవుతున్నాయో, so that is equal to number of asymptotes. గుర్తుపెట్టుకోండి. That is p minus z always. So p is 3, z is 0. 3 minus 0, how much you are getting?
3, sir.
So that's why 3 asymptotes are there. So asymptote అంటే ఏం లేదు, how many root locus branches which are going to approaches to infinity. That root locus branches we are calling as asymptotes. Simply formula is p minus z. 3 asymptotes are there. Am I right, Amma?
Yes, sir.
Next. So 3 asymptotes. So compulsory 3 asymptotes means angle of asymptotes. Let us calculate. Angle of asymptotes. Let us calculate. Calculate చేయండి అమ్మా. What is the formula for angle of asymptote? What is the formula? Sangavi. What is the formula for angle of
Yes, sir.
asymptote?
Theta is equal to 2q plus 1 into 180 degrees by p minus z, sir.
So what is Q? Where Q equal to?
Q equal to 0, 1 and p minus z minus 1, sir, up to.
P minus Z minus 1 formula apply cheyi. So 3 P equal to 3, Z equal to 0. So minus
2,
1.
sir.
How much? So 2. So up to 2. And
Yes,
up to 2 means Q equal to 0, 1, 2. Am I right?
0, 1, 2. Yes, sir, yes, sir.
So 0, 1, 2. So now if you apply 0, if you apply Q equal to 0, what is the angle of asymptote value? What is the angle of asymptote? If you apply
180 by 2, 180 by 3. 60, sir, first 0 apply cheste.
Next one, if you apply 1.
2 ante 360 by 3 ante 180, sir.
2. If you apply 2.
Yes, sir. 2q అంటే 2 to 4 5 into 180 by 3 అంటే 900 by 300, sir.
300. Okay, na?
Yes,
So
sir, yes.
3 angle of asymptotes. 3 angle of asymptotes. So these angle of 60 degrees, 180 degrees, and 300 degrees. These are the angles which gives the direction to the root locus branch, which approaches to infinity. Clear? Okay, help చేస్తాను అన్నమాట మనకి. రూట్ లోకస్ బ్రాంచ్ పోల్ దగ్గర స్టార్ట్ అవుతుంది. సో ఎండ్ దగ్గర జీరో దగ్గర ఎండ్ అవ్వాలి. మనకు జీరోస్ లేవు కాబట్టి సో మనం జీరోస్ ఇన్ఫినిటీ దగ్గర ఉన్నాయని మనం అనుకుంటున్నాం. సో ఎన్ని జీరోస్ ఇన్ఫినిటీ దగ్గర ఉన్నాయనుకున్నాం? 3. అంటే ఏంటి? 3 root locus branches are going to be terminated infinity. So that's why. So number of asymptotes is equal to 3. So అందుకని so angle of asymptotes 3 you are going to calculate. So these 3 angles gives the direction to the root locus branches which approaches to infinity. Clear? Are you clear, Sangavi?
Yes,
So
sir,
immediately,
clear, sir.
immediately after calculating the asymptote, immediately you can calculate centroid. Why means centroid is nothing but what is centroid, Amma? It's the intersection point of the asymptotes on root locus. Just read it, Amma. What is the centroid formula and calculate.
The point of intersection of the asymptotes on the real axis is called centroid. It is given by sigma is equal to sum of real part of poles minus sum of real parts of zeros by p minus z.
So sum of real part of poles, manaku only poles are having. So one pole is 0, another pole is
0,
-5,
and next one is -10, sir.
So how much you are getting?
-15, sir. We are getting p minus z is p is equal to 0. P is equal to 3 and z is equal to 0, sir. So p minus z is equal to 3. So we are getting -5, sir.
Okay, very good, Amma. So keep in your mind the centroid you are getting -5 and the asymptote 60 degrees, 180 degrees, 300 degrees. Okay, Amma?
Yes,
60,
sir.
180, 300.
300.
Keep in your mind. So centroid is -5. So just they are plotted here. Yeah. So here they are plotted, Amma. Yeah. So simply they are plotted. See, first one is Chondamma. So real axis and imaginary axis. This is real axis and this is imaginary axis. Imaginary axis and real axis. So 3 asymptotes they have to drawn. Chondamma, what is the first one? What is the first asymptote? 60 degrees.
60 degrees.
So centroid first, before going to first centroids draw cheyandamma. Centroid ante enti? That is a intersection point of asymptotes. అందుకని మీరు ఏం చేస్తారంటే ఫస్ట్ indicate the centroid on real axis. What is centroid value, Amma? How much? -5.
-5, sir.
Yeah. So there you can okay na, you can indicate it. This is -5. At this point, okay na, you can draw 60 degrees from real axis. So real axis నుంచి 60 degrees పాయింట్ తీసుకొని సో లైన్ డ్రా చేయండి. జస్ట్ డ్రా ఎ లైన్ దట్ ఈస్ θ1. చూడమ్మా ఇక్కడ ఇండికేట్ చేస్తుంది చూడండి. దిస్ ఇస్ θ1. కనిపిస్తుందా అమ్మా? 60 degrees θ1
కనిపిస్తుంది సార్.
దట్ ఈస్ θ1. సో నెక్స్ట్ అసిమ్ప్టోట్, యాంగిల్ ఆఫ్ అసిమ్ప్టోట్ ఎంత అమ్మా? నెక్స్ట్
180 సార్.
సో యా చూడండి. సో రెడ్ మార్క్ చూపిస్తున్నాను చూడండి అమ్మా. So this is theta 1. Am I right?
Yes, sir.
Red mark చూపిస్తాను చూడండి. Red mark. So this is theta 1. Next theta 2. So next theta 2 చూడండి. Red mark. All of you observe. This is theta 2. Okay. Theta 2
Okay,
and
sir.
how much? 180 degrees.
180
ఎంత?
degrees.
Yeah. Next ఎంత? Next angle ఎంత?
300 degrees. 300, sir.
Yeah. Next 300 degrees. చూడండి. Red. I can use red mark and I can show it. This is 300 degrees. So 3 asymptotes theta 1, theta 2, theta 3. I drawn. Okay. Am I right, Amma?
Yes, sir.
So these are the 3 asymptotes and this is the indication of the asymptotes, angles and the centroid. So మీకు క్లియర్ డయాగ్రామ్ డ్రా చేస్తాను చూడండి. సో యాంగిల్ ఆఫ్ అసిమ్ప్టోట్స్ ఎలా మీరు డ్రా చేసుకోవాలి, లేదంటే గ్రీన్ మాకు కనిపిస్తుందమ్మా. ఫస్ట్ theta 1 let us draw like this. Where I started, sir, means from the centroid you can start it. So this is 60 degrees amma, from real axis to theta 1. This is 60. Next 180 degrees కనిపిస్తుందమ్మా. 180 degrees, that is theta 2. Next will be theta 3.
300.
Yeah, that is 300 amma, that is 300 degrees. So like this you can okay na, like this you can indicate them, like this you can indicate. So మీకు మీ దగ్గర ఉంటాయి కదా ప్రొట్రాక్టర్స్, ఇవన్నీ ప్రొట్రాక్టర్స్ అవన్నీ. సో మీరు ఇంటి దగ్గర డ్రా చేయాలమ్మా నార్మల్ గ్రాఫ్ మీద. సో రూట్ లోకస్ మీరు డ్రా చేయాలి. సో దిస్ ఇస్ సో ఓవరాల్ గా నేను మొత్తం కంప్లీట్ అయిన తర్వాత ఎక్స్ప్లెయిన్ చేస్తాను హౌ టు డ్రా. సో ఫస్ట్ ఇండికేషన్స్, how to draw the asymptotes, how to indicate the centroid and how to indicate the poles, open loop poles and open loop zeros. Okay na, till now. Next, after calculation of centroid, next point amma, what is the next one? Breakaway point. Is there any breakaway point or not? Is there any breakaway point or not? How to determine the breakaway point amma? Sangavi, I already gave the first characteristic. Let us write the characteristic equation. Okay.
Okay, sir.
Second step enti, after writing characteristic equation, second
We have
వచ్చేసి
to
form the polynomial, form the equation k equal to f of s. So k ని మనం LHS తీసుకొచ్చేసి remaining part RHS వైపు తీసుకెళ్ళాలి. So that is the equation, second step, k equal to some function f of x. So చేసామా మమ్మ? 1 plus చదవం ఒకసారి breakaway point ఒకసారి.
Breakaway point 1 plus g of s into h of s is equal to 0. 1 plus k by s into s plus 5 into s plus 10 is equal to 0. S into s plus 5 into s plus 10 plus k is equal to 0. S cube plus 15 s square plus 50 s plus k is equal to 0. K is equal to we have to get the value of k, so k equal to minus s cube minus 15 s square minus 50s.
So k equal to k is a function of something. So later, what is the next step amma? Apply differentiation with respect to s.
Okay.
So
Yes.
if I and then equate to 0 and then equate to 0, you know
0.
already how to do the differentiation. After differentiation,
Yes,
what is the equation you are getting?
Minus 3s square minus 30s minus 50 is equal to 0, sir. We have to remove minus, so 3s square plus 30s plus 50 is equal to 0.
So then this is a second order quadratic equation. If you find out the roots, minus b plus or minus square root of b square minus 4ac by 2a, by using that formula you are going to have two values. Am I right?
Yes, sir.
You are
Thus
going to
on
have these.
solving, roots obtained will be minus 2.113 and minus 7.88.
After getting the roots, so ikkada meeru chaala important. So two roots you are getting, which one is valid root and which one is invalid root? That is very, very important calculation. Which one is valid and which one is invalid? So that is very, very important. Yeah. So next step chadavamma.
As the root minus 7.88 falls beyond the predicted section for the breakaway point, thus s is equal to minus 2.113 is the valid breakaway point.
Valid breakaway point. Yes. See, simple amma, chaala simple ikkada. So మనకి ఇక్కడ అంతా minus 2.113 and minus 7.88. So Here, if I take. So minus 2.113 and minus 7. See, 2 breakaway points you are getting. 2 breakaway points you are getting. So minus 7 point. In between minus 5 to minus 10, is there any real axis? Is there any root locus? Anyone? In between minus 5 and minus 10, is there any root locus? So if I consider one point here, I can consider point here. I can consider a point here. Sangavi, I can consider point.
Yes, sir.
For example, minus 4 and Kondi. So to the right of minus 4, how many? If you add, how many number of poles and how many number of zeros? To the right side. To the right side. Make right side over. To the right side of this one, this area. How many number of poles and how many number of zeros?
One pole, sir.
One pole only. And that is odd number. That is
Yes,
odd
sir.
number. So odd number means according to the rule 2 or rule 3. So the root locus exists between these two. The root locus exists between them. Clear, Amma?
Yes, sir.
Okay. Next, if I take the point here, if I take the point, for example, minus 6, if I take to the right of this point, how many number of poles and zeros?
2, sir.
2. Is it even or odd?
Even, sir.
So if it is even, there is no root
Yes.
locus between these two. There is no root locus between these two. So there is no root locus, Amma. There is no root locus. Am I right?
Yes, sir.
So there is no root locus. If I write? So NRL. NRL means no root locus. Here, the root locus. So after 10, if I take minus 11. To the right side of this, is there any
3, sir.
3 is an odd number. Odd number means compulsory. There is a root locus.
Root locus. Yes, sir.
There is a root locus. So from minus 10 till minus infinity. Till minus infinity. There is a root locus. There is a root locus. Till minus infinity. To minus infinity. Up to minus infinity. The root locus exists. The root locus exists. So 0 to minus 5, the root locus exists. Minus 10 to minus 10, the root locus exists. But minus 5 to minus 10, is there any root locus?
No root locus. No, sir.
No. So now the point. So now the point is here the breakaway point. What is the breakaway point? Minus 7.88. Is it valid or invalid?
Minus 7.88 invalid, sir.
Invalid. Why? Because there is no root locus in between minus 5 and minus 10. So there is a valid point. There is a valid break point. What is the valid one? Minus 2.11.
Minus 2.113.
Yes. Minus 2.113 is the valid one. Minus 2.113 is the valid one. So up to one root locus branch starts at 0, another root locus starts at minus 5. They are moving like this. Actually. They are moving like this. So one root locus branch, it is moving like this. Another root locus branch, it is moving like this from 0. So they are going to come and they are going to meet at one point. That point is called minus 2 point. How much am a breakaway point? Minus 2 point something. So there, that is going to, the root locus is breakaway. So another root locus branch starts at minus 10 and it is going to be ended infinity. So e root locus same problem. It is going to be ended minus infinity. It's going to be ended minus. Clear? So which one is valid one, Amma? Which one is valid one? So minus 2.113 is the
minus 2.113. Yes, sir.
Is a valid one. Next. So I can save it, Amma. Just I can save it. Next, after calculation of the breakaway point, what is K value? So at this, if it is valid one, then if you substitute in the form of S is equal to minus 2.113, Then K. So if I substitute it minus 2.113, then the K value is getting, how much K value you are getting? How much K
Therefore,
value?
on solid K equal to 48.11.
Yeah. Keep in your mind, K equal to 48.11. So at K equal to minus, S is equal to minus 2.11. So K is a positive value, hence S is equal to minus 2.11. This is a valid one, So up to this is one, and next one. Under follow to So after calculation of breakaway point later. So breakaway point వచ్చిన తర్వాత చూడండి. So ఇందులో మనకి breakaway point వచ్చిన తర్వాత here they are coming, these two branches coming at some point there is a breakaway point. So after breakaway point చూడండి, they are coming like this. At one particular point. At one particular point, that is minus 2.11, minus 2.11. So they are going to break. They are going to meet them. They are going to meet at this point. So they are going to meet at this point, and they are going to break away. So okay, minus 5. From minus 5, it is going to be start and coming the journey like this. It is moving towards right side at one point, that is at minus 2.11. Minus 2.1. This is the breakaway point. So at this point, these two are breakaway, and this root locus branch moving like this. That is given by the angle of asymptote. Already angle of asymptote draw చేస్తాం. So ఇలా draw చేస్తాం. Angle of asymptote 60. అదేవిధంగా ఇటువైపు వచ్చేసి 300. ఓకేనా? సో ఇటువైపు వచ్చేసి 180 degrees already drawn.
180.
So this shows, this angle of asymptote shows the direction of to the root locus. So the root locus branch is moving like this, but where it is going to be touches the imaginary axis. అదేవిధంగా ఇటువైపు where zero దగ్గర start అయిన root locus branch comes to this like this, and it is breakaway like this, and it is moving like this. That is given by the theta 3. So 360, 300 degrees angle of asymptote ఉంది కదా. That is given, that gives the direction to this root locus branch, and it is moving like this, and it is also moving like this. But where it is going to be intersect with the imaginary axis, we don't know. Where it is one second. Power one. 1 second, Amma. Time lo power పోద్దాం. See, okay. So this is the direction, and so where these two root locus branches. So 3 root locus branches అన్న మనకి ఫస్ట్ ఒక root locus 10 దగ్గర స్టార్ట్ అయ్యే root locus branch కి ఎటువంటి ప్రాబ్లం లేదన్న. So it is moving like this, and it is going to approach us to infinity, so without any deviation. So with 180 degrees angle of asymptote. So theta 2 angle ఉంది కదా, with this the help of 180 degrees angle, this root locus branches approaches to infinity. అన్న. So ఈ branch problem ఉండదు. There is no problem with this branch. There is no problem. But the problem with these two branches, breakaway point calculation, and where these two branches are going to be interact with the imaginary axis. That is what we are going to find out. Next. Yeah. So how to, okay, next చూద్దాం. The point of intersection of root locus branches with imaginary axis, so that can be calculated with the help of the Routh-Hurwitz criteria. చూద్దాం. సో మనకు తెలిసింది Routh-Hurwitz criteria, SQ plus 15 S square plus 50 S plus K equal to 0. This is the characteristic equation. So if you do Routh-Hurwitz criterion, so you are getting, చదవం ఒకసారి సంగవి. So what is the Routh-Hurwitz table? ఒకసారి చదవం ఒకసారి. S cube.
S cube 1 to 50 sir. S square 15K. S1 750 minus K by 15 0. S0 K. S power 0 K.
Yeah. Okay, ma'am. So in order to get S to the power of 1 row is complete zeros. What is the K value? Let us take. S to the power of 1 row 0 రావాలి అంటే row 0 రావాలి అంటే K value ఎంత తీసుకోవాలి? How much K value? Let us take 750.
750. Yes sir.
If I take K equal to 750, then S to the power of 1 row, all row should be 0. Okay. So Km, if I take K equal to 750, then entire row will become 0. So if all row will become 0, then auxiliary equation, let us write the auxiliary equation. What is the auxiliary equation you are getting? The row above zeros, 15 S square plus K.
S square plus K. Yes sir.
Auxiliary equation already మీకు చెప్పాను. Rule, I mean case 3 RH criteria లో case 3 గురించి చెప్పాను. A row of all zeros, if you get the row above all zeros, that will become auxiliary equation. That is equal to, so what is the row above all zeros? 15K. So S square row ఉంది కాబట్టి 15 S square plus K.
S square plus K equal
0. So K value, let us take 750. What is the S value you are getting?
Plus or చదవనా sir?
చదవండి.
Therefore S is equal to plus or minus J root 50 sir. S is equal to plus J 7.07 minus J 7.07 sir.
Plus J point, okay, 07 minus J 7.07. So at these values, these two root locus branches are going to be intersect with the imaginary axis. Ante kadamma?
Yes sir.
But what is the K value for this intersection? What is the K value for this intersection? 750. Km is 750. Okay. So yeah, now I'm going to explain everything. This is the root locus. All of you draw. మీరు అందరూ కూడా ఈరోజు ఒక గ్రాఫ్ తీసుకొని కంపల్సరీ డ్రా చేయండి. సో రియల్ యాక్సిస్ అండ్ ఇమాజినరీ యాక్సిస్. సో what are the roots అమ్మా సంగవి? S is equal to 0, S is equal to -5,
S equal to minus 10.
minus 10. So these are the three roots sum. So 0, minus 5, minus 10.
5.
So 3 root locus branches మనకు కావాలి. 3 root locus branches. So next మీరు immediate గా centroid చూడండి. Centroid indicate చేసుకోండి. What is the centroid value? Minus 5.
Minus 5, sir.
So centroid. So minus 5 pole కూడా minus 5 as well as centroid is also minus 5. So at minus 5 there is a point of intersection. It's a intersection of asymptotes. అంటే 3 asymptotes intersect అయ్యే point అమ్మ. So 3 asymptotes. What are the 3 asymptotes we are having? What are the 3 asymptotes? 60.
60 degrees, 180, 300.
Yes, this is 180. This is 1. So this is 60. అంతే కదమ్మా, this is 60. 60 and 180 and this is 300. అంతే కదమ్మా?
300, yes.
So
Yes,
this
sir.
is centroid. This is centroid point. It is minus 5. This is minus 5. అంతే కదా? So based on the angle,
Yes, sir.
you can draw it. You can draw it. So if you draw the same thing, if you draw it, so you are getting చూడండి. So this is theta 1. Theta 1 చూడండి. Theta 1. Yeah, this is theta 1 now. So this is theta 1 they are drawing. చూడండి. From minus 5, theta 1 let us draw. That is 60 degrees. Okay, Namma? Next.
Yes.
From minus 5, there is one more. It is minus 180 degrees. 180 degrees. You can draw like this. 180. అదే విధంగా
300.
So 300. So these are the 3 asymptotes they are drawn. 3 asymptotes they are drawn. So after drawing asymptotes draw చేసిన తర్వాత 3 root locus branches where they are going to be start. చూడండి ఇక్కడ. So one root locus branch starts at where, amma? One root locus branch starts at where? I already told you, at 0. Okay, na?
Zero.
Start. 0 దగ్గర start అవుతుంది. This is coming towards left side as k is equal to increasing. చూడండి అమ్మా. సో మీరు k వాల్యూ కంపల్సరీ ఇండికేట్ చేసుకోండి. సో ఎక్కడైతే మనకి రూట్ లోకి స్టార్ట్ అవుతుంది, దట్ ఈస్ k వాల్యూ అమ్మా. దట్ ఈస్ k ఈక్వల్ టు 0 వాల్యూ. Here also k equal to, what is the value of k? K equal to 0. So here k equal to 0. అర్థమైందమ్మా? k equal to 0 కనిపించింది అంటే, so at that point the root locus starts. చూడండి ఇక్కడ some green color they are using. So from 0 it is moving like this. It is moving. ఒక 5 minutes కొంచెం వెయిట్ చేయండి అమ్మా, కొంచెం అలా. So at 0 it is moving like this. It is moving like this. It is moving like this. Okay, na? It is started. One root locus branch. Another root locus branch starts at minus 5. Another root locus starts at minus 5, and it is moving towards right side. Ante kadamma? Towards right side.
Yes, sir. Yes, sir.
So they are going to be meet at one point. They are going to be meet at one point. That point is called, what is that point?
Breakaway point.
Yeah, breakaway point. So they are going to meet at breakaway point. How much value? That is minus 2.113. The breakaway point is minus 2.1. Minus value kadamma? Put picture.
Yes, sir.
So minus 2.11. Minus 2.113. They are going to be. Okay. They are going to be. Yes. So this is minus 2.11. Next. So at this point, they are going to be meet, and the journey. How the journey is going to be happen. What is the journey? How they are going to be move? So at 0 one root locus branch starts, and at minus 5 one root locus branch start. They are moving like this. They are connected. They are meeting at a breakaway point minus 2.113, and so one root locus branch takes this way, moving upwards, and another root locus branch moving downwards. So these two directions given by which? These two directions given by asymptotes. This is the direction. So this is the direction, like this. అర్థమవుతుందమ్మా? They are moving like this.
Yes, sir.
They are moving like this. So they are going to intersect with the imaginary axis at what point? So the upper. So this is at play plus j 7.07. It is going to intersect, and this side minus j 7.07 is going to be intersect. Already the values you are getting. Chudamma. S is equal to plus j 7.07. S is equal to minus j 7.07. So they are going to be intersect, and finally they are going to approach to infinity. And they are going to approach to infinity. See the second. So infinity దగ్గర approach అయ్యే కాబట్టి ఇక్కడ k value వచ్చేసి infinity నోట్ చేసుకున్నాం. So k value equal to infinity. K value infinity నోట్ చేసుకున్నాం. నేను రాస్తాను. So k equal to infinity. Here also k equal to infinity. So 3. K equal to infinity, k equal to infinity, like this. So infinity already రాశారు అక్కడ, but that is k అమ్మ. K equal to infinity. So అర్థమైందా? Like this, the root locus travels like this. This is a journey of the 3 root locus branches. They are going to be started open loop poles, and they are going to be ended open loop zeros at infinity. So now, very important point now it is. So for what values of k it is stable, and for what values of k it is marginally stable, for what values of k it is unstable. Chodamma. So k is k between 0 to 750. So 0 to 750 entire the root locus on left hand side. Chodamma. So at k equal to 750 only it is going to be marginally stable. Am I right or wrong? Amma Sangavi.
Yes, sir.
Up to k equal to 0 to 750. Up to k equal to 0 to 750. Entire root locus is on left hand side. Ante kadamma.
Yes, sir.
At 750 only it touches the imaginary axis. So what it means, so from k equal to 0 to 250,
Sure.
from k equal to 0 to 750 only,
Sure.
the system is stable. Why? Because the complete root locus lies in the left half of S-plane. At k equal to 750, the root locus touches the imaginary axis. So that means it is marginally stable. After k equal to 750, and k equal to 750 above. Okay, now after 750, the k value. So the root locus enters into RHS right hand side. So now after k 750, k equal to 750, the root locus enters into right hand side. RHP plane. So then the system is unstable.
Unstable.
So this is the prediction of the stability. For what values of k it should be stable. For what values of k it should be marginally stable. For what values of k it should be unstable. You are going to predict it. Amma. So clear amma? Ardhamainda? So this is what already 12:23 amma time. Sir, attendance తీసుకుంటాను fast గా. 1 second wait amma. So 18 batch 83. Respond oh babu. 83. Yes, sir. మా శ్యామల అర్థమైందమ్మా మీకు? 77.
Yes, sir.
అర్థమైందమ్మా?
Yes, sir.
So all of you draw the root locus on the normal graph sheet మీద డ్రా చేయండి అమ్మా. నేను మీకు వాట్సాప్ లో సెండ్ చేస్తాను, ఇప్పుడు పోస్ట్ చేస్తాను. సో ఫర్ దిస్ ద సేమ్ డయాగ్రామ్ షుడ్ డ్రా ఆన్ ద గ్రాఫ్ బై యువర్ ఓన్. సో దెన్ ఓన్లీ యు ఆర్ గోయింగ్ టు అండర్స్టాండ్, అదర్వైజ్ ఇట్ కాంట్. చేస్తారు కదా?
Okay, sir. Draw చేస్తాం సార్.
A2 absent, A3, A4, A5, A6, A7, A8 absent, 12, 13, 14, let enter 14 absent, let enter 16 absent, 17, 18 absent, 19, 20, 22 కూడా absent. So 18 to 83, so leave అయిపోయాడు. సరే బాబు, సరే అమ్మా. టుమారో
కాల్ డ్రాప్ అయిందండి సార్.
ఎవరిది బాబు?
ఎల్ఈ 18 సార్.
ఓకే అటెండెన్స్ ఇచ్చాను అమ్మా. ఎవరు 83? ఎవరు ఇప్పుడు మాట్లాడిన వాళ్ళు? నేను 83. హలో 83. సరే రిమైనింగ్ పీపుల్ అందరూ లీవ్ ఇవ్వండి అమ్మా. 12:25 ఆల్రెడీ. ఆల్ ఆఫ్ యూ లీవ్. సో 83. ఒకసారి నాకు కాల్ చేయమ్మా. 83. ఐ కెన్ లీవ్. ఐఎమ్ గోయింగ్ టు లీవ్ అమ్మా. అందరు లీవ్ అవ్వండి.